Now let's consider the same example where we want to estimate our sample size, n, but in this situation, you'll see that we're given a little bit more information. So here, we're told that, so again, we want to know how many randomly selected sales transactions must be surveyed to determine the percentage of transactions that transpire over the internet. So that's P, okay, so that value there, let me grab my pen here, that's P. And we want a 99% confidence interval, so confidence level, I'll write this down, is 0.99. Our margin of error, no more than 2%. So go ahead and convert 2% to its decimal equivalency. And then we're also told here that if we assume a previous estimation places that proportion at about 0.35, then we have the following value. So here, this means that there is a previous study, so a previous value for p hat. So our sample proportion here is 0.35. So we can use that same formula where n is equal to our critical value, z sub alpha divided by 2, times p hat times q hat over e squared. Okay, so in this situation, notice that p hat is known, right? And so we can go ahead and use this to calculate Q hat, which is the complement of P hat. So if 35% or 0.35% of the transactions occur online, then that means that Q hat is 1 minus 0.35, okay? All right, so let's go ahead and remind ourselves of the critical value. So Z sub 0.01 divided by 2, which is the same thing as Z sub 0.005. If you use your calculator and use the inverse norm function, that gives us a critical value of 2.58. So let's put that into the formula, 2.58, okay? Type in 0.35, right, times 1 minus 0.35. Divide this by 0.02 squared. Right, this calculation gives us a sample size of 3,785. So this means that your sample needs to be at least 3,785 sales transactions or larger to ensure our margin of error is no more than 2%.